we're going to be dividing rational expressions. So dividing rational expressions are equivalent to multiplying rational expressions, except you have to take the division and turn it into multiplication. And the way we do this is you'll see right here in our 4 steps, the very first step, this keep, change, flip, that is what gets you from division to multiplication. So you keep the first fraction, it doesn't change, flip the division for multiplication, and flip the fraction of the second one. So take what's on top, put it on the bottom, take what's on the bottom and put it on top. Then from there on, the steps are exactly the same as multiplication. You factor, cancel, multiply across the top, multiply across the bottom. So our first example is 25 over 9m cubed divided by 15 over m cubed. So anytime I see division, I change it to multiplication. And the way I do this is keep, change, flip. Keep the first, so 25 over 9m cubed, that doesn't change. I change the sign to multiplication, and I change the second fraction, or I flip the second fraction. Now it looks just like the multiplication. This is the only step that's different between division and multiplication. Now I look if there's something I need to factor, which all of these are monomials, so there's nothing I factor, so I go straight to canceling. So 25 and 15 I can divide out of 5 and get 3 and 5. And then on the other diagonal, m cubed and m cubed will cancel out completely. So I'm left with 5 over 9 times everything canceled on the top. So that leaves me with a 1 over 3. Now, because I am to my fourth and final step, it's multiplication. I'm going to multiply across the top, 5 times 1, and get 5 over, multiply across the bottom, and get 27. So I've got 5 over 27 is my final answer. So the first thing that I notice in this second example is here I have a division symbol. As soon as I see division, I have to do keep, change, flip. So I keep the first fraction exactly the same. I flip, or I change the division to multiplication, and I flip the second fraction. So I've got x plus 10 over x squared plus 2x minus 48. Keep, change, flip. So I kept the first, changed the operation, flip the second. You may have heard it as keep, change, change. Same thing. Now that it's turned into multiplication, I go to factor. I have to factor before I can cancel, unless I just have monomials. So in the previous example, I had monomials. I just had one term all around, so I could cancel without factoring. Notice here in this first one, first left, that is a trinomial. I cannot cancel trinomials and binomials without factoring. You cannot just say that those x's will cancel. That is not a true statement. Do not fall into that trap. So I'm going to go through and factor all of these. I'll have x and x. I'm looking for two numbers that will multiply to 12 and add to 8. So because this is a positive 12, that means they're going to be the same sign. They are both going to be. So two numbers that will give me negative 8 and multiply to positive 12 will be negative 6 and negative 2. Now on the bottom, x plus 10, that doesn't factor. I can't take anything out. Okay, on my other side, I've got x plus 10, which again doesn't factor. And on the bottom, I'm looking for two numbers that will multiply to negative 48. So that tells me they're going to be opposite signs. And will subtract, because they're opposite signs, or it's the same thing as adding a negative, to negative 2. My two numbers are 6 and 8. Now I need to figure out which one's going to be positive, which one's going to be negative. The positive number is going to be the bigger number. Because that b is positive, I need 8 to be positive, 6 to be negative. Now I'm ready to cancel. Because I factored, now I can cancel. So I look for things that will cancel. X minus 6 will cancel, and x plus 10. So I am left with x minus 2 over 1, because that denominator went away, and 1 over x plus 6. Anytime a numerator or a denominator cancels completely, you are left with a 1 in its place. So I don't see anything else that will cancel. I multiply across the top, and I get x minus 2, and I multiply across the bottom, and I get x plus 6. So my final answer is x minus 2 over x plus 6.